Number one, thank you everyone for attending. This is fantastic. ETHDenver is just kicking off, but already has great energy. Little introduction about myself. My name is Robbie Kruszynski. I'm part of the Chronicle Labs team. I'm the lead of DevRel there. Admittingly, I joined about a month ago, but it's been really fantastic. And I'm going to give, in 15 minutes, kind of a quick overview of what Chronicle is in terms of what we're providing, why we're separate, and why I think we're really interesting for you to start exploring. So why don't we start out with, may I see a show of hands, who is familiar with Chronicle? Okay, fair. So let's talk about the table of contents. We're going to be talking about the introduction to Chronicle, the current landscape of oracles, why Chronicle, deeper dive into what the Chronicle architecture is, and we'll ideally have some time for a remix demo. So my next question is, who here is familiar with Maker? Ah, yes. So you might be thinking, oh, like you've never heard of Chronicle. It must be some sort of new protocol. Chronicle protocol is actually an Oracle solution that's been exclusively securing the assets for MakerDAO in its ecosystem since 2017. So actually, Chronicle was the first Oracle on Ethereum, and it was made for MakerDAO. And so when it comes to us exclusively securing those assets, since 2017, we've secured about $10 billion, right? So Chronicle's been around for a very long time, very, very long time. And only recently has it started to expand outside of Maker in terms of what we're trying to do. So I pulled this actually today. If we look at DeFi Llama, and we look at the scope, we can see that Chronicle is actually in the #2 position when it comes to the total value secured. And we're floating at, I want to say, 22%. So yes, it is very real. So let's talk about oracles today, right? As we could see on that left-hand side, we're just looking at price feeds, right? So with current price feeds being provided, a quick question I would ask all of you who are like developers or are curious in this, how can you ensure the accuracy, right? Number one, how can you ensure it? Who are you trusting? What vision do you have when it comes to data availability? What sort of data can you actually look at? If you wanted to dive deeper with the asset pairings, how would you go about doing this, right? That's a question that I think a lot of us have maybe overlooked in terms of, oh, what's the data that I actually have, available to me? And if we go ahead and we look at that top right, we've all seen those transaction fees. We've seen the ebbs and flows of how expensive that can be, right? Oracles cost, there's no denying, a considerable amount to operate. Gas costs to run oracles is certainly something that can't be ignored. Gas prices, as we've seen in the past, can have massive fluctuations. So what does this mean? This means at a certain point, it can be very difficult to maintain your project based on the current gas prices. So this boxes a lot of protocols out. This boxes a lot of projects out. Unless you're able to eat those fees, this becomes very difficult, especially during tumultuous times in the space, which we know will come and go as it normally does. So why Chronicle, right? So our goal is to build infrastructure that allows the founding ethos of decentralization and transparency to actually flourish, right? We ensure the convenience, but no longer at the cost of true decentralization or verification. We are a mission to develop frictionless, decentralized, and verifiable infrastructure for all on-chain data transmissions, right? So what do we focus on? Cost efficiency. We focus on scalability. We focus on verifiable data. We focus on the ability to plug and play because we know this is important for developers. We focus on being decentralized. And we focus on reputation and security. This is something that we really take to heart. This is our ethos. And we really have a lot of pride in terms of what we're trying to accomplish. So let's go ahead and let's get under the hood. Again, this is a 15-minute talk. So we're going to stay a little high level, but I will be very available and happy to dig into this. So when we talk about our validators, we have decentralized validators. You'll hear me use the term validator and feeds. These are like we could transfer these terms. So a validator is a feed when it comes to our nomenclature, right? So Chronicle operates as a validator consensus model, right? Chronicle is powered by a decentralized group of validators known as feeds, right? So each validator is run by a renowned project. And you might think, oh, who are your validators? Here are some examples. So as you can see, very reputable companies that most of us are using day to day. What's interesting about this, though, is because we are using these people, or rather these companies, the validators are also staking their reputation. Obviously, we know in this space, reputation is quite important. And if you lose it, it can be very difficult to regain this. So it is in everyone's best interest to avoid acting, maliciously and to ensure all of the data that is provided is as accurate as possible. And Oracle has, our oracles have, a canonical value, which is obtained by a majority consensus of this consortium of validators. This essentially means that to trust the Chronicle Oracle, it boils down to how much does one trust the ecosystem of the Web3 applications that we use every day. And of course, as the number of validators / feeds grows, the stronger this guarantee becomes. So hopefully you can see this, the architecture at a very high level. So the Chronicle Oracle protocol comprises of a distributed architecture spanning both on-chain and off-chain components, right? So the diagram highlights both of these components. The off-chain components depicted are going to be on the left side, and those are going to be green. And then the on-chain components are going to be purple, closer to my side. So we're highlighting both the on-chain and off-chain components. And so essentially what's happening is from the dashboard, which we can see on the top left, that's going to be feeding in. And hopefully, is this legible? Can everyone read this? Fantastic, great. So what we're doing is, we're pushing down to the archiver. That's going to be going to the validator. That's fetching information from the origin. A quick note that the origins can be on-chain or off-chain, such as a primary data source, so they can exist on both sides. And so we're fetching that raw data. That validator is taking that data and it's pushing it down to the relayer. The relay is going to be collecting this data from the validators and creating a transaction that's going to occur on the EVM. We also have a challenger, which is listening and verifying the optimistic updates to see if it needs to be challenged, if there's a malicious occurrence to ensure that all of the information is correct. The relay and the challenger are going to be then pushing onto the Oracle, and then the validator is going to be giving a list of all of the allowed validators to the feed registry, and then it's also going to be giving a list of the appropriate models for the quorum and the validators into the WAT registry. So hopefully this makes sense. Again, it is quite high level, but I'm trying to compress quite a bit in a short amount of time. Again, I'm happy to continue this conversation. But we are going to be discussing this workflow a little bit later on in the presentation. So let's talk about Scribe. Like, what is Scribe? Scribe is the name of a new type of Oracle architecture developed by the team at Chronicle Labs. The design is built around 5 pillars. It's built around scalability, transparency, accessibility, resilience, and security. Scribe is an incredibly efficient, gas-efficient Oracle based on aggregated Schnorr signatures, right? And so this is where it becomes really interesting, is because we're using Schnorr when it comes to our architecture. So providing nearly consistent gas costs on layer 2s and layer 1s, Scribe boasts on fixed prices, essentially leading to substantial savings, over 60% on L1s when it comes to competing oracles. We are cheaper by 60%. When it comes to layer 2s, about 68% cheaper. When it comes to some of our biggest competitors, we are about 80% cheaper than some other oracles that may have dominance in the space. So this approach to gas management significantly boosts the scalability of our oracle. So let's first take a look at the landscape pre-Scribe for just a moment. So prior to Scribe, architecturally, all blockchain oracles used a standalone implementation of an elliptic curve digital signature algorithm, ECDSA, to the general public. To generate public keys to cryptographically authenticate the identity of the signer or the validator, and therefore the integrity of the reported data. The more signers or the validators that an Oracle protocol has, the more it would cost the Oracle builder or the operator to update to the latest report data of that Oracle, right? Makes sense. This is because every signer or validator must individually sign the message to attest its integrity. But this ultimately means that those looking to utilize oracles have to consider the pros and cons when it comes to the importance of cost, speed, and decentralization. Generally, one of those things is going to fall back a bit if you focus on 2 other ones. If you really care about decentralization and speed, it will probably be more expensive. If you really want it to be cheap and fast, probably won't be that decentralized, right? So there's a bit of a conundrum. One is always going to fall a little shorter if you are focusing on the two. But now we can talk about Scribe. So Scribe has kept accessibility in mind while being designed. This was something that was very top of mind while our incredible engineers were working on it, right? The iChronicle interface is a plug and play for protocols that are already using, let's say, Chainlink or our oracles to simply swap out the contract addresses and you're already off to the races, right? So we make it very easy for developers to start to experiment with what we're providing at Chronicle. Chronicle's end-to-end verifiability ensures, let's say, DeFi. I bring this up because DeFi, of course, is right now a big driver when it comes to adoption. It's top of mind for everybody. So this is why I bring this example up. It enables DeFi dApps with liquidation functionality to offer unrivaled transparency. Right? This is really attractive for the builder and for the user. Who doesn't want transparency, right? But there are many examples of poorly designed blockchain oracles reporting inaccurate prices, or price data rather, which then has led to illegitimate liquidation of users in DeFi projects, right? And this is very difficult, right? This is really difficult to swallow, but it is a reality. So there's never a question of whether the Chronicle Oracle was operating as intended. Every aspect of any reported data is verifiable on our on-chain dashboard and is legible to all blockchain users regardless of their expertise. And we're going to see an example of this on the next slide. And hopefully we'll have some time and we'll be able to see this in real time. So what you're seeing is a GIF that I've made, but what we're doing is we're looking at our dashboard and we're looking at a collection of ETHUSD, that data feed, and we're looking at our validators. And so what we've done is I've picked one of the validators and I'm looking at the ability to look at the raw data. So everyone has the ability to look at the raw data and you can verify that the data is accurate. So you can see that data and verify it in browser literally with a click of a button. You can see the clip that I've done. I've changed the timestamp upon trying to verify right here. You can see on that second line, and it errors out. So this is accessibility for users being able to look at the raw data themselves. It's something that we really pride ourselves on to ensure full transparency. Right? So now let's talk about scalability with the help of Schnorr. Right? So scalability is very important, right? It's really everything when it comes to our space. Not just with oracles, but in general, we really have to think about scalability. So Optimistic Schnorr signature aggregation unlocks 66% of gas improvements. As I mentioned earlier, this is tremendous, right? This can't be ignored. This is a substantial amount of savings. So what does that mean? So now we're looking at our Optimistic Schnorr, right? So a Schnorr signature is an algorithmic scheme similar to, let's say, BLS, right? With Schnorr, you can verify on-chain in more effective manner as opposed to BLS, at least right now. So Schnorr is actually quite attractive to build with, and that's why Chronicle has chosen this. Right, so validators sign and create an aggregated signature. You have one signature and one validator, and the signing of the correctiveness of that signature. And then we have a relay, which is a permissionless function, right? So it pushes the Oracle update payload, which includes the Schnorr signature, the ETHDSA sign, the validator performed, as mentioned one click above, the data, which is going to be the payload, i.e. the price, and the timestamp. The Oracle smart contract verifies the relayer, passing the signature that corresponds to the payload, the ETHDSA signature, and the signer is the validator, and the timestamp is recent. So what's really interesting is what we've done here is, we've verified the relayer is passing that signature that corresponds to the payload, the signer of the signature is the validator, and the timestamp is recent. And then what happens is we now have a price, and that price is going to be the optimistic price. What's interesting is we don't verify, all we do is we verify one ETHDSA signature. We do not prove the Schnorr signature. We don't do this because, again, we are trying to keep the gas prices low. So what we do have is we have an optimistic model that has a challenge period, which is a function that could be called to verify the Schnorr signature. So if you run the challenge successfully, i.e. you catch something that is being malicious, that validator has proven to be faulty, so they're immediately booted and they're no longer a validator. So now what happens is we drop the optimistic price, and the challenger, due to proving this negative act by the corrupt validator, then claims the ETH that was inside of the Oracle contract as a reward. So this creates an incentive to help ensure the validity of all of the data that's happening. So what does this do? This ultimately, this architecture ultimately provides, again, on L1 gas improvement by 60+%, on L2 improvement by 68+%, while providing transparency, decentralization, accuracy, and security. So if anyone has a computer and they're curious, we're going to try to run this. It's a very simple example. It's a remix example of essentially an Oracle reader. I'll give a second for you guys to scan it. What it's going to do is it's going to take you to our docs. You just go to the tutorial, go to remix, and then you can see the contract there. But what we're going to try to do is we're going to try to do this. Oh, man, this is all backwards. Bear with me. I'm sorry. OK, so here's our contract. And so I can't see it. Shoot. We'll figure it out. So here's our contract. And so now what we're going to do is we are going to go ahead and we're going to compile our contract. Oh, geez. I really can't see. Sorry. 1 second. We are going to compile our contract. And now that we've compiled our contract, we are going to go ahead and we are going to head over to deploy. And what we have to do is we have to ensure that we're on the right network. This has been hard-coded to test Sepolia. And so now we are just going to wait for this account to pop up. And so what we're doing is essentially we're going to be able to fetch the current price of Ethereum. Oh, forgive me. So what I didn't do is I did not set the correct contract. So we are going to go to our Oracle reader. There we go. And now we're going to go ahead and deploy it. And so really, as we could see, there's not very much code in order to do this. In fact, there are more lines of comments than there are codes. But what we're doing is we have our kisser, we have our Chronicle contract, we have hard-coded this to the testnet just for the sake of the example, and we are going to be able to read once this deploys. And it looks like it is working on deployment right now. Yeah, we're pending. So once this deploys, we're going to be able to see a couple things. We're going to see the Chronicle contract pop up. So we should be able to see this address. And then we're going to see our kisser address, which is going to be here. And then we're going to be able to read. So if we go down here, there we go. So we can go ahead and we can click on Chronicle. And this, of course, is going to give us that address as we were expecting. And we can go ahead and we can click on our kisser. That's going to give us that address as expected. There we go. And so now we are doing a read. And so we can see right here that we've already fetched the data, and we can already see the time as well. Because if we look at this function, and forgive me, I can't see so well. I believe it's right here. We can see we have an unsigned integer giving us the value and an unsigned integer giving us the age. And the team at Chronicle has done an excellent job when it comes to documenting and creating really fantastic comments when it comes to all the functions to walk everybody through everything if there is any curiosity. So I do encourage you to look at our documentation and especially look at our GitHubs, look at our repos, because the documentation in there is also very, very robust. So again, this is a very simple contract, but it does show you like how easily you could just start to spin up. Also, when it comes to our tutorials, we have kind of cooked in something quite similar to this into Scaffold ETH2. So if you're curious to play around with this, we've done the .env.example. We've put a couple things in there, and then we also have a contract cooked in under hard hat. So all you have to do is switch networks, and you should be able to deploy, create the front, and you're off to go. You're off to the races. So if we head back to, and here's an example of the dashboard. So let's go ahead and let's just click on, I don't know. Well, actually, we could click on validators. And so now if we look at our validators, we can look at their last update. And we can essentially look at any information we want to. And so we can look at the pairings in which anyone is, verifying any information. But if we wanted to look at, let's say, ETH to USD, so we can go ahead and we can see that we have the ability to verify. Let's go ahead and let's verify with Infura. And so if we go ahead and click this, we can see that it's taking the median price across all of our validators, and it's showing us the raw data right here. And so now if we go ahead and we just verify, we can go ahead and we could see that that's correct. If we make any adjustments to this, which you can in browser, in the raw, then it would error out, as was demonstrated earlier. But I think that's really powerful that you could do that in browser and very quickly see and experiment with yourself. I do want to be mindful of time because I think I'm just about done. If you want to get in touch with me specifically, there is a QR to my Twitter. Otherwise, it's just Robbie K. But more importantly, get in touch with us, the team. The team's going to be coming later this week. There are going to be 2 codes down here. On the left-hand side, you are going to see our hackathon details. So if you're curious about this, I suggest you give that a scan. We've got some, we're looking for innovation. We're looking for really interesting projects, and we've got a lot of things documented there. And then on the right-hand side, it's just going to be leading to our website, which very easily you can go into the documentation, or you can go to the community element of it. And I would suggest everyone join our Discord. We're very active in there. And we, obviously want to nurture curiosity. So we want to continue to, develop the product that we're building. And with the assistance of everyone that's curious, obviously we want to ensure that we're listening to the people that are using our product, and we're implementing that into our future development. So I just want to say thank you everyone for attending. Thank you everyone at ETHDenver for putting this together. I know it's a huge endeavor, especially with the amount of people. And specifically, thank you so much for Chronicle for giving me the opportunity to represent the team and for giving me a try. And with that, thank you everybody.